Hello everyone, welcome back to my channel. My name is Isha. My channel's name is Isha Nagpurkar. I am a data science and business analysis intern at the Sparks Foundation, and this is my presentation on the task given by the Sparks Foundation. Earlier, I had posted one video on task 1. The task 1 was prediction using supervised machine learning, and task 2, that is this one, is prediction using unsupervised machine learning. So in this presentation, I will be explaining the task 2. So let us move ahead. The contents of the presentation, here I will be explaining. It contains introduction, iris dataset, model building, results and conclusion, and references. So coming to the introduction, here I will be explaining a little bit about problem statement and about supervised and unsupervised machine learning. Iris is a flower species. There are various categories in this. For now, we are considering 3 different species: Iris versicolor, Iris setosa, and Iris virginica. The difference in these 3 species is about their petal and sepal features. So here you can see this is the sepal and this is the petal. So you can clearly see in these 3 different species the petal and sepal have different characteristics. Over here the sepal width is more and here the sepal width is less. Similarly, the petal width is less and petal width here is more and petal width here is less. That is how we can differentiate between these two. Similarly, these 3 categories. So coming to our problem statement. Here we have to develop a machine learning model that can accurately classify iris flowers into their respective species based on specific botanical features. The data set contains 4 different attributes: sepal length, sepal width, petal length, and petal width, with which are measured in centimeters, along with the corresponding species label Setosa versicolor and Virginica. The goal is to create a robust classification model that can be used to automatically identify the species of iris flower from these measurements with a high degree of accuracy. Supervised and unsupervised machine learning. Unsupervised machine learning, in this, the algorithm is not provided with any target values or categories to predict. Instead, it tries to identify the patterns, relationships, or structures within the data on its own. So, the definition of supervised and unsupervised machine learning. What is supervised machine learning? As you can see here, this is an image of apples. So, we give this image as an input to the model. While we give this image to the model, we also tell the model that this is an image of apples, that these are apples. The model trains itself. We provide the model several different images of apples and we tell that these are apples. And thereby, the model, when we come up with an input without annotation, it can clearly predict that it is an apple. But in unsupervised machine learning, here for example, we have given this image to the model wherein there are a lot of different fruits. It is not only apple, there are different fruits, but the model doesn't know which one is apple and which one is the other one, which one is the other one, this banana. So the model here tries to find out the relationship between them and classify them into apple and banana. Similarly, in the iris dataset, we have given the characteristics of the different species and we have asked the model to train itself and give it as an output. So in this case, the model doesn't know, as in the model, when we give this as an input, we train the model to learn that this image contains different classes, and we ask the model to classify the fruits into these two different categories. So similarly, we are doing it with this iris dataset. For that, we are using different types of algorithms. One is SVM, support vector machine, one is logistic regression, one is decision tree, and one is k-nearest neighbor. The dataset and the tools used here are given here. The dataset is given here. We have used Python Jupyter Notebook. So the dataset clearly tells you that we have been given sepal length, sepal width, petal width, and we have been given the species name. So for a particular, so each row represent each different flowers. So for flower number 1, the sepal length is 5.1, sepal width is 3.5, petal length is 1.4, and petal length is 1.4, petal width is 0.2. So with all these features, it is specified as a iris setosa. So similarly, we have defined the characteristics of iris versicolor and virginica also, and thereby then asked our model to find that this is the relationship between these inputs and outputs. We first train our model. We tell the model that when sepal length is for a flower, when the sepal length is this much, width is this much, petal length and width are these, it is setosa. And in case of when it is versicolor, these are different. So we train our model like that, and then we give a test data to the model. We only give these parameters we only tell the model that we only have the data related to sepal length, sepal width, petal width, and ask the model to identify what is the class of uh, class over there. So let us see how we do that in a machine learning like how we do the coding of this. So for that, we do how we build the model is we load the data, we analyze and visualize the data set, we do model training, we do model evaluation, we do the testing of the model, and finally we represent the results. So let us go to the code now. So this is the code for unsupervised machine learning on our iris dataset. So first of all, we import the necessary libraries, that is NumPy, Pandas, and also we import Seaborn and Matplotlib, which are for visualization. So first of all, we read the iris CSV, which is stored in my folder, which is given here in this particular folder where I have mm, this code Python file. There only I have kept this CSV file, so it can read from there. Then we see the head iris dot from with high iris dot head. We can see the first 5 rows. With iris dot info, we get to know what are the different types of what are the different data types here present. So the column ID is integer. Similarly, the different columns are float, and there is one column called species, which is an object. Then removing unneeded column. So here the ID column is not required as such. So we drop that. Then some IDA with this iris data. So first of all, we plot the given data as and we try to see with the help of this chart if we can differentiate between the three species. So first of all, we do a scatter plot between the sepal width and sepal length. So we can clearly see here that the orange colored are setosa, the blue colored are versicolor, and green color is virginica. However, we can, as per the features, for say for when sepal length is 6, then the sepal width lies between somewhere around 21. Similarly, when sepal width is 21, around 21, the sepal length is say somewhere around 6.2. So this doesn't give you any clear indication that these species are different. This is a data belonging to two different species. We cannot identify that. So we go ahead and we see some other plots. We plot the sepal width. We plot the petal width versus petal length. Here we can actually observe that these three different categories lie on the scatter plot at different locations. So it means that petal length or petal width or petal characteristics are crucial in defining these different species. Now, the given problem is a classification problem. Thus, we will be using classification algorithms to build a model. Classification samples belonging to two or more classes, and we want to learn from already labeled data how to predict the class of unlabeled data. Whereas regression is if the desired output consists of one or more continuous variables, then the task is called regression. An example of a regression problem would be the prediction of length of a salmon as a function of its age and weight. So before we start, we need to clear some ML notations. Attributes. An attribute is a property of an instance that may be used to determine its classification. In the following dataset, the attributes are the petal and sepal length and width. It is also known as features. Target variables. In the machine learning context, target variable is that is or should be the output. Here the target variables are three flower species. So in order to do the machine learning, we import some all the necessary libraries. Here we are importing logistic regression. We are importing the train test split, which is used in every machine learning problem in order to split the dataset for training and testing. Then we import k nearest neighbor, that is the KNN classifier. We import SVM, that is support vector machine algorithm, and we import the matrices which are required to check the accuracy of the model, which are required to compare the model performances. And we also import decision tree classifier. So the shape of this iris dataset is 150 rows to 5 columns. Now when we train any algorithm, the number of features and their correlation plays an important role. If there are features and many of the features are highly correlated, then training an algorithm with all the features will reduce the accuracy. Thus, feature selection should be done carefully. This dataset has less features, but still we will see the correlation. So with heat map, SNS.heatmap, we find out the correlation. So this correlation, it shows that the sepal width and the sepal length, these things, they're not correlated. The petal width and petal length, however, are highly correlated. So we will use all the features for training the algorithm and check the accuracy. Then we will use one petal feature and one sepal feature to check the accuracy of the algorithm, as we are using only two features that are not correlated. Thus we have a variance in the dataset which may help in better accuracy. We will check it later. So steps to be followed when applying an algorithm are, first we split the data into training and test dataset. The testing dataset is generally smaller than the training one, as it will help in training the model better. So select any we can select any algorithm based on the problem. Here it is a classification. Based on classification and regression, we can select the model, whatever we feel better, and then pass the training dataset into the algorithm to train it. We use the dot fit method, then pass the dataset training dataset to the trained algorithm to predict the outcome. We use the dot predict method. We then check the accuracy by passing the predicted outcome and the actual output to the model. So splitting the data into training and test dataset is done by this command, and thereby we see that in the the train part of that dataset there are 105 rows, whereas 45 rows have gone to the test dataset. So then uh, we then split the train dataset into x and y variables. X is input, y is the output. Similarly, test also we split into x and y, that is input and output. And we see by using dot head, we have a look at the data. So first of all, we define support vector machine. We use this model. So we use model svm.svc and then we fit, and then we do prediction also, and then we print the accuracy of this SVM. So the predicted accuracy of this SVM model is about 95%. So this is actually very good. So we will continue to check the accuracy for different models, and now we will follow the same steps as above uh, for various machine learning algorithms. So from logistic regression, we can see that the accuracy is 95%. From decision tree, it is 93%. K-nearest neighbor, it is 93%. So let's check the accuracy of various values on of the n for k-nearest neighbors. So here this above graph shows the accuracy of KNN models using different values of n. So most of the times it is above 90%, which is good. So we use all the features of this iris in above models. Now we will use petals and sepals separately. Creating petals and sepals training data, we define petal and sepal separately. We only take the petal length and petal width and the species in the petal dataset, and in sepal dataset similarly we take sepal length and sepal width and species. So for iris petal, we define the train and test datasets, and for iris petal we do that, and for iris sepal also we define train and test datasets, and we apply the SVM algorithm. So we can here clearly see that the sepal part of uh, the sepal part of this dataset has less accuracy than the petal part. By using SVM algorithm, by using logistic algorithm, also the accuracy of sepal part is less than that of petal part in decision tree also, and in k nearest neighbor also. So our observation is that using petals over sepal for training the data gives a much better accuracy. This was expected as we saw in the heat map above that the correlation between the sepal width and length was very low, whereas the correlation between petal width and length was very high. Coming back to the slides, as we have seen in our code, we have tested various algorithms. So we have seen that the results of the algorithm say that accuracy of SVM and logistic regression models is 95%, whereas for KNN and decision tree it is 93%, which is fairly good. So thereby we can conclude that the model has been trained, tested, and validated, and we are able to classify the flower into respective category based on the given input. So we can use this classifier model for any type of classification problem. So thank you so much for watching. Please subscribe to the channel because I will be coming up with a lot of experiments and projects ahead. In this presentation, I've shown you the code, but later on I will also try to explain the different models that we have used here. So stay tuned. Thank you.